Okay, let's see. Can you hear me?
Yeah, we can hear you.
I'm in my office, so then I work on my laptop, and God, everything just is so tiny on the screen. Um, okay, so I thought maybe first I would ask people about homework. How is the homework coming? There were a lot of visitors to office hours for Finley the other day, and I've received quite a few emails. So, any questions on the homework? No. So what about on the newer homework? Let's see if maybe I can get up and share my screen on homework. Has anyone started trying homework 7?
I started. I'm kind of having trouble with it.
Uh, so I mean, we can kind of go over this static and dynamic scoping rules again. The key is what you save when you encounter a let me share my screen. What you save when you actually encounter the declaration. I mean, there's a couple of rules. Let's see. God, it's just microscopic. All right, there we go. Share screen. So this is homework 7, and this is the stuff we've been going over. Now, when I went and looked at the code, just now I've been looking at the code, well, for like 5 minutes. We have a faculty meeting right before this class every other week. It's so frustrating. I don't have any, it's hard to get the time with that meeting right before this. But this is saying, look at the rules on page 92 and 93. And so if you look at those rules, I don't know, you can see what the difference is. I guess I can go back, actually, let me go to the notes that we used last time, because this is what we've been going over. I have to say that I felt like some of the questions on the previous homework were, I don't know, it seemed like maybe you're not, you know, reading the book, but maybe you are. Maybe this is just confusing. It seems like you should be able to read those rules and figure out what the right thing to do is. Let's see, here's the scoping rules PDF. I don't know, maybe I should download it and might be able to make it bigger. Of course, the default viewer has some kind of maximum size. So where did that go? Scoping rules.pdf. Let me I don't know. What happens if I do that? Is that bigger? That might actually be the best thing I have right here. So, okay, so the thing to look at is the difference between well, so first, one surprise I started to say that I found in the code is that the code that's in this homework matches the book perfectly. So we don't have this kind of putting together the various environments into a single record. That I think was something that I did in the next bit of code once we started dealing with parameters, or maybe even until we dealt with records. But so what do the rules look like, though, for declaring a variable and the rules for declaring a procedure, depending on whether or not you're doing the dynamic rules or not? And see, here's the dynamic rule, and in mine and his. When you see the declaration of a procedure P and the body S, what you do is you update the envp part, adding a new name P in and mapping it to S alone. And that is different from what you do in the static case, where what you want to happen is you want, got to go down here. You want to remember what the declarations were that were in place at the time that the procedure declaration was encountered. So when I'm evaluating the body here of P, what I want to have is I need to have the body, but I also need to have what are the environment variables that were in place at the time that this thing was encountered, and that was env sub v, and so I put that in there, and I put in the procedures, the procedure environment, env sub p goes in there. So I've saved S1, comma, let me see if I can make this even bigger because it's still a little bit hard to read. There's an S1, I've saved S1, that comma goes right almost over it. But so this is a triple with the environment and with the procedure in place. Now, what am I doing here, though, is I evaluate so there's a semicolon followed by possibly more declarations. And so what do? Well, on this line, we're evaluating all the rest of the declarations, but we're evaluating the rest of the declarations in the environment, in the procedure environment that's been updated to record envv and envp at the time of the call, but we're evaluating the rest of the declarations in the procedure environment that now knows that P gets mapped to this triple. So is there any question on that?
Could you maybe go over the dynamic?
Well,
Um,
yeah, we did that
the
last time.
right, but the actual this little derivation tree of how it connects play with the code in the dynamic, maybe.
Well, we did it not by doing the whole derivation tree, but just by assuming that you can figure out what those rules are saying and what does happen to the store, the procedure environment, and the variable environment. So we can go over this once more if people, want to. Does anyone not want to see this again? Speak up now or forever hold your peace. Let me know. Say, no, we already did this. Why are you doing it again? All right, let's look at what happens. So at line 1, we start out with an empty store, an empty procedure environment, and an empty variable environment. At line 2, we do two things, because when you allocate a variable, you change the store and you change the environment, the variable environment. So you make an entry, here you call the allocate function, which takes care of messing around with the pointers. And it says, okay, the next location available is 0 because nothing's been allocated yet. So the variable name X gets bound to the location 0. And location 0 gets bound to the value 0 because that's the default value we want to put in there. So does anyone have a question about what happens on that first line? Or the second line, I mean.
No, that makes sense.
Right. So when you see a variable declaration, you add an entry to the var environment and you update the store because you've allocated new variable space. So when we see this line, we don't get rid of the X. We now make Y go to loc 1. We haven't seen any procedures yet, so we just extend the variable environment to have one more entry. And now the store has an entry that says, okay, loc 1 points to 42 because that was the value that we had there. Now, maybe I need to, the next one is proc p is X gets the value of X plus 3. And here's where kind of the magic of this comes in, because what's going to happen is we're going to put away, we're going to say, okay, we're going to update. We don't change the store. Declaring a procedure does not change the store. So in a way, this is kind of a lazy evaluation. Like one thing you could do, but it would be kind of weird and dumb, is, you could evaluate this expression right away and change the store. But no, when you declare a procedure, you're binding a name to an expression or to a statement that you're going to refer to later. So what goes in the store is, and I think you can't really, unfortunately, can't really see it. I've got off the edge here for some reason. It got cut. P gets bound to, first of all, the statement, X gets the value of X plus 3, and ENV3. And I basically say EN up above, you can see this red line in a circle, and that's what's in ENV3. So that means if we ever call, what we're going to do, if we ever call P, we're going to use this environment for the variables X and Y. And so X will refer to location 1. So it will refer to this first declaration of X. And in the next line, we have a new entry in the procedure environment that says, oh, if you ever see a Q, what you do is you call P, and when you call P, the environment that you use is environment 4, and that's the environment that was in place at on line 4. So it included this stuff for X and an entry for P, but no entry for Q. Okay? So now line 6 begin, doesn't really have any effect. Line 7, I declare a new variable, and oh gosh, it's too bad this is getting cut off, but this is loc 3. This is location 3. And it gets the value 9. And that's the end of the store, has now location 0, 1, and 3. And the values are 0, 42, and 9. And what's kind of missing here is, well, it's not missing, is that the entry for X now points to location 2, because location 2 is what X refers to in the body of this begin end block nest, which is nested in, excuse me, inside this other one. Let me grab a drink. And so on line 7, now we do have this loc 3, or I'm sorry, loc 2, because we're 0 based. The third location, X points to that. And once we go past this declaration of X, we don't really have any way to mention X and refer back to this first X. It's gone, and it's gone from the environment. So what happens on line 8? Now we declare a new procedure, P. And so now P gets bound to the statement X gets the value of X plus 1 and environment 7, which is, this is the procedure part of environment 7, and this is the variable part of environment 7. Does that make sense?
Yeah.
Okay. Now then, on line 9, we call Q. And so if you go back and look, okay, we're going to say, okay, what is Q? Q, but we can find it right in our, on line 9, we call Q. So we go over here and we say, okay, that means call P using environment 4. And so we don't just look in our current environment. We don't say, oh, okay, P gets the value of X plus 1, which is what we just did. We go back and we look at environment 4, and environment 4 said P is X gets the value of X plus 3. And for the variables, use environment 3. And in environment 3, it's this X that this X refers to in the definition of P. And so calling Q called P and updated location 0 to now have the value 3. Before, location 0 had the value 0. So when I call P on line, or I'm sorry, when I call Q on line 9, I'm actually calling this P, which is updating this value. So it changes location 0 to have the value 3. Now on line 10, I say, okay, Y gets the value of X. Now I look up in the environment, what is Y? Y is location 1. Okay, but what is X in the current environment here? X is location, I've got this little picture of all of us here that's blocking my view. X is location 2. So we end up, when we execute that, we say, okay, Y, location 1, gets the value of what was in location 2, which is 9. And so now this is the store. And when we get to environment 11, we essentially revert back to the environment that was in place when we entered this block. So whatever environment 5 was, this one here is what the new environment is. And then in 12, when we exit the first block, we lose the environment completely. We don't have any. So what does the environment do? It gives you a handle on locations in the store and the definitions of the procedures. And so we end up with this final store. Now, you know, we've kind of lost the connection at this point between the variable names, but the meaning in this semantics and in the semantics for this programming language all over the place, the final meaning of a program is it's the store that results from evaluating the program. So I don't know. Does that help? It is does that help?
Yeah, that makes more sense.
It's an extremely, I think, beautiful mechanism where when you see P, you don't just put away the body that you need to evaluate, whatever the code is. You also put away the information that you need to evaluate this code, which is contained in the environment. But you don't leave it so that, okay, you know, if we called P again, like if we called Q down here, or we called P, if we called Q again, let's say, then this would become 6. So any questions?
I had one question. I was just trying to test just like some of the individual methods or functions at a time. And like I was just wondering for statements, how do you write a statement in Haskell? Or like what's the criteria?
Well, I don't know. The names on this are unfortunate. I think I forgot to capitalize, but anyway, okay. So here's the code that I give you for this next homework, which is all the code for doing the dynamic evaluation. And if you look in here, where's the definition of statement? Oh, it's up. So here's the so this one is even as bad as, like, this first implementation I did of this. I just followed the book, and then I realized, oh my God, how much do I hate this decal V followed by the decal P? More than you can imagine. It's just a kind of a dumb constraint that he put on his language. But anyway, so how do I write a statement? Can you see the text on this? I hope it's not too small.
Yeah, I can see it.
Yeah, it's good. It's actually pretty big.
Okay, so now I've loaded this code from BIPs, from the file above. And so, I mean, suppose I wanted to write, you know, let's say I'll comment, I'm saying like X gets the value of X plus 3. How do I write that? Well, I use the assign, and the var name is X, and I forget, is it plus? And then what's the constructor for A expressions is V for a variable in an A expression, V, X, and then I forgot what is the constant. Is it num? And so if I say, hey, what's the type of that thing? It says, oh, that's a statement.
Gotcha. That makes sense. I for some reason was thinking statement was like a like a string or something. I missed the data structure for that. My bad.
Right. Okay. So this code, now I think in this code though, I still did one thing different from him. If you look at the book, on, let's see, where does he use it? There are, so like, for call, static, which is on page 93. He's messing around with where the next pointer is. Where's the next pointer? And he stores the next pointer in the envv variable. And in this implementation here, I'm storing the next pointer in location -1, and I'm storing the max pointer, which he doesn't include, but it really helps to be able to print out memory, for example, for at the end of like viewing what is in the store. You do -Q2, and that tells the max memory. And then for anything else, the default S0 is just an error because you haven't put anything in there. But after you run allocate, you'll get back the location that got allocated with the store that's been modified to have that new location, but also with F-1 and F-2 properly updated, which is the next. And so I don't know, is there anyone that doesn't have their book available? Really? Everyone has the book right in front of them. Okay.
Yeah,
Well,
I'm
that's
at
good.
work, but I can look at it tonight.
Okay. On page 93. I mean, I can write down the rule. It's the call rule. Well, let's go look and see how we implement call here, because this is the dynamic call. And so in the dynamic rule, you just in the dynamic rule, you just look up, it's just a statement. So when you do this look up proc P in the environment for procedures, all you're going to get back is a statement. And so we can evaluate it with big step statement, whatever that statement. This thing here is going to be the body, and you don't change it. You don't do anything with the environment. And so the key is going to be like updating this. And all right, so I mean, how could I make this right? Well, I'd have to say something like, so I'm writing your homework for you right now. How come I don't hear cries of joy?
Yippee-ki-yay.
Okay. I mean, I'm only doing one part. You got to do the declarations, and you got to do it for procedures, the declaration for procedures. So I don't know, maybe I shouldn't do this, but I mean, what you're going to end up doing is you're going to do this lookup proc thing here is going to give you back like an S, which is the statement to execute. I'll call it body. It's the body of the procedure. And you're going to get back ENVV1, and you're going to get back ENVV2. And that's the result of lookup proc, which you're going to have to modify so that it does this right thing, or maybe not. It actually will do the right thing without changing it. So once you have that, now you can figure out how to evaluate this. So, I mean, you could even put it on the upper line, but you could say STO prime equals what? Let me show you the rule again. Oh, God, I wish I had a picture of the rule. Well, I can write down the rule. What does the rule look like for this? The rule looks like, for him, ENV, comma, ENVP. Now, why does he have these outside, to the left, to the left of the turnstile? It's because evaluating a statement does not change the environment. You might say, well, wait a minute. What about begin? Well, it doesn't actually change the environment that's already set up. It creates a new environment, essentially, that gets used. Well, I mean, you use the current one, but if you ever see any decal V's or decal P's, that's going to modify the environment. So you do big step DV, which is the declaration, the variable declaration. So you evaluate all your variable declarations, and then you evaluate your procedure declarations. That's the decal P part. And now you get back like, okay, when you evaluated your variable declarations, what you got back was a new environment that knew about the new variables that were declared and the new store that are pointed to by the variables. And when you do the procedure declarations, all you get back is the ENVP prime thing. And so now what do? So this is a begin end block. This doesn't change. You do the big step semantics on the body S up here. but you use the store that you got back, and you use the two environments that you got back. And so now you're evaluating S in a richer, well, if there were any declarations here, in a richer environment than you would have if you just evaluated S without dropping N. So the begin N doesn't really do anything. So none of the statements, all of the statements, the meaning of a statement is just a store. So he doesn't include them in here. And then he says, okay, now we're looking at the actual statement, which is call some procedure P. And because statements change the store gets included in the configuration. And so we're going to do this. We're going to assume that we get back some store, but where do we get it from? Well, what are some of the things that we need to do? Well, we need to say, we need to look up the statement, and he does it, I think, does he do it right in place? No, he does it separately. He says, okay, STM oh God, what does he say? He says where ENVP applied to the name P is equal to, and he calls it in the rules called capital S, comma, ENV. So we're V prime, comma, ENVP prime. And then, like, this is an interesting little twist that he does, which you don't have to worry about. But he says, you know, and L is equal to ENVV next. So, whoops, L is equal to ENVV next. And so then up above, he says, take ENV prime. So that's the environment when P was declared, that was in place for variables when P was declared. It should be ENVV prime. And modify that one so that next points to L. And then use ENVP prime. And now, and we'll talk about why is he doing that? And then you just evaluate S, and you haven't changed the store yet until you evaluate the body of the procedure. And that's going to give me back my store prime. So what is this rule saying? It's saying, okay, if I want to evaluate a call, whoops, that should say call P, the command call P in this store, what do? The first thing I do is I look up the meaning of P in ENVP, and so I look up the meaning of P by applying the environment, which is a function, to P, and returns the triple, which is the store, I'm sorry, the body, which is the statement S, the environment, the variable environment that was in place when this procedure was declared, and the procedure environment that was in place when the procedure was declared. So what's he doing here? Can anyone guess? Or maybe you've read the book and you actually get it. Like, it would be better if you don't have to guess. Oh, this makes me sad. I mean, I should be such a better teacher. I should be giving you quizzes like every day, Saturdays and Sundays included. Quizzes actually cement knowledge. I just find them kind of silly. Like a good scholar kind of like poses little questions for themselves as they're reading this kind of technical material, which is what I hope you will do. So what could this possibly be?
Is just getting the next location set up for a new variable to be assigned.
He is, but that's good. That's exactly right. But why is he bothering to do this? Well, because, like, if you look at the evaluation that we were doing here, we don't know if calling Q the body of Q might be a begin end block. So it might allocate more storage. And we certainly don't want to clobber the storage, because back in the environment when like in this case, when Q was declared, which was on line 5, when Q was declared on line 5, there were only 2 locations. And later, though, when we call Q on line 9, there's 3 locations. Now, in this particular instance, Q doesn't allocate any storage, but if it did, it would be writing over storage that was possibly being used when we exit the block. So this bit of code that he does here is he updates the next pointer to point to where it should at the time the call is seen. So this will avoid, when we evaluate S, if S allocated more storage, we don't want it to allocate storage on top of storage we're already using. We need to push the pointer along. Now, we don't need to worry about like updating the environment, either environment, because the only thing gets returned is the store. So these environments disappear. You have to look at the semicolon rule to see, which is this one, to see how the environment gets passed along. So I say, okay, look, I want to evaluate S1 semicolon S2. That's the seek constructor. We're sequencing these 2 statements so that S1 is evaluated first and then S2 gets evaluated. So what do? Well, we go down here and we say, okay, use these environments and evaluate S1 in the store that we have at the current time when we see this seek thing, this sequencing statement. And so what do? We evaluate that, and that gives us back a new store. And then the answer is, okay, and now evaluate S2 in the same environment and variable and store environment, because these evaluating a statement does not change the environments, but it could change this evaluation here, probably change the store. So we have to use store prime here, and then this is going to return a new store. So sequencing is making sure that the stores get passed around. But if you look at all the code, well, assign is one of the only ones where you actually do something. You update the store so that whatever location X points to has the value of whatever when you evaluate A in the current store. And so you put that value in X. That's where you use this update store feature, and you apply that to this store here. So you're updating current store. This is going to be a new store that knows that X now points to this value. But skip just returns a score. Sequencing returns a new store, but the one that you get from executing S1 followed by S2. If then else, same thing, you use the same environment in two environments everywhere. Same thing for while. Now begin, you know, you evaluate the local declarations, and that gives you a modified environment for envv and a modified environment for envp, and then you use those to evaluate the body of the block. Okay, so if we went back here and we look at this rule, how do I write down what store prime is when, okay, so this is my S body. I mean, we could write it initially as like capital S. And I guess I could write this as ENVV to match the rule. So how do I get the answer? How do I get this?
What are the two environment variable primes? Where are the two of them coming from?
They come from, you have to modify the procedure environment envp so that not only does it save the body S, but it resaves the two environments. Oh, this one should be envp, sorry. env and envv and envp, so that this thing returns, lookup proc returns a triple now. But amazingly, you don't actually have to change the code for lookup proc unless it's got a type declaration. It doesn't. You just got to change this to include more stuff. It's got to include the variable environment and the, so this thing here isn't just statement, it's a triple of a statement, a variable environment, and a procedure environment. So when I call down here to look up proc P in this procedure environment, it gives me back this triple. Now, here's the rule, and I'm trying to write the code. Here's the code that worked for dynamic, and now I'm trying to write the code that matches this rule, which is what your homework is. I'm doing half of your homework.
So would it be, you call the big step statement again, like in the previous one, and then The look.
That's okay. Called big step.
And also, I don't know, the version I downloaded doesn't have it has the way you kind of had designed where the environment variables and procedures are in one data set and are used together in one environment data type.
Did you get the homework from the?
It's what I
I am a
download.
little concerned about this because I just linked to whatever was last year. So,
So whatever code you're showing today is different from what I've been looking at, but it's the same thing, but it's separate. The separated variable and
well,
procedures are the
let's
same
make
thing.
sure that we're not messed up, because let me go to assignment, because I don't want this to be a problem, you know, like over the weekend or over the break or whatever. So when you download this file, that's the file I've been editing today. So it should look exactly like this, which has.
So yeah, if you see like that data environment variable.
All right. I'm working from an old BIPS. Oh, I'm sorry. All right. Well, that means I'm not exactly doing your homework. That's probably better. But you have the right idea. So what do I want to do? Big steps, STM.
And then use the environment variable prime in the environment variable p prime, and then look up on the environment variable prime, maybe.
No, I've got my statement is call P.
Oh, so use S.
Is S,
comma,
right?
And then store, just regular store.
Yeah. Okay. Let me call this body. All right, so that's it for this code. Now you've got slightly different code. I didn't realize. God, I don't know. What a shame. I've got too many. I should be, you know, I'm like not a I'm like a complete novice Git user. I should have been using Git for years. How many people use Git? Raise your hand. Can I see hands? All right. Well, if you're not using Git, you ought to learn it. I mean, it's actually like it's a giant gap in my. I mean, when last time I worked in a like commercial, you know, like in a software development environment, it was like make files and SCCS were the state of the art, and it was kind of a nightmare then. And then Git has really revolutionized the whole source code control thing. But I'm still like I keep thinking I ought to get all this stuff put under Git, but okay. So let's see, what should we do now? I mean, I don't think we have time. Well, where are we? We're at, it's 4:15 or 2, I'm sorry, 2:15, 2:16. So now I'm wondering, where is that BIPS file? It must be down here. See, I've got like, I'm so disorganized on this. I've got, does this one have the record? It still has those things separated. Oh, I know what I can talk about a bit. Is no, this still has a separate one, huh? I don't even know where that file comes from then. The one that's uploaded to Wild Courses last year. I'll have to download, make sure I have the proper ones downloaded when you ask questions. If you come to office hours. But I know what I can talk about. Like there seemed to be like quite a bit of confusion about this, and so in the book, you know, and mathematically, well, and in the book, what's going on here? Oh, I'm in the HS file. I guess I should be. I'm trying to use Markdown. I don't know. Does anyone use Markdown? It's kind of, you know, it's like this dumb little language, but it generates your HTML for you, and you can generate PDFs from it too. So it's like it's not like heavy duty like LaTeX is, where you're typesetting everything, but it helps. It has a few things. I oftentimes forget like what they have, but so anyway, stores and environments. Mathematically and in the book, you know, we think of like a store as something that maps locations to ints. And we think of, I don't know, if I use his notation, ENVV, okay, what is that? That takes an identifier and maps it to a location. And then the ENVP takes a location. I'm sorry, it takes an identifier. And I'm just saying, like, you know, I'm just using this instead of string because maybe string can be confusing. These are identifiers. Not every string might, you know, you may not want every string to be an identifier, because then you get stuff like you can write programs or languages like white space, where the only characters are white space characters, and you can't see the programs. And you might have rules for, you know, oh, variables are always start with a lowercase alpha character, and then whatever. So identifier for ENVP goes to a statement, or it goes to a statement and an ENV. So this one is for dynamic scoping, or envp is a function that maps identifiers to statement paired with an envp v and an envp. Okay, that's what we just been talking about. But so this is like, you know, it's a little bit weird, but the one that we're storing away is the one that was in place before this new one. If we go back, if I could find that role, I think this is the wrong one. We're expecting to get back when we call envp, which is one of these procedure environments. We expect to get back a triple. So we're in this world here. This is for static scoping roles. And well, you're going to have to write the declaration, which is the one that puts it all away. And that code is down below here. It says, well, if I see a proc P and S, then it used to be you just update and add P and S to whatever the environment was in place at the time. And this was, you know, this is the environment that you get by recursively evaluating these more proc declarations. And what do you evaluate them with? You, let's see, what is this one doing? Update. Is this code actually wrong? No, you evaluate this and get back NVP prime, and then that's the one that you should be using over here. But now you're adding in that P is updated to S. That is a little bit, I think it will work, but I think it's not really logically the right way to go. So this is the declaration. And so when you have a declaration, that's when you're building this thing and putting that information away. But the thing that I think that people, I don't know. So does anyone have a question? All right. I mean, in a way, I feel like in like when I wrote up the other homework, I felt like I needed to emphasize that, you know, you could use, you know, if S is a store and X is an identifier, how do you look up and I guess I need to say such that, you know, X is in the domain of, so if S is a store, ENVP is something of type, oh, I want the variable one. ENVV is something of type ENVV. And X is an identifier such that X is in the domain of ENVV. Then to look up the value of X, like before we had this thing state in the first version, and state went from identifier to int. And so now if you want to look up the integer value of X, what do? Well, you say S dot ENVV applied to X. And so the dead horse that I felt like I was beating too much was to remind you that, you know, F composed with G applied to X is equal to F applied to G applied to X. And I felt like, okay, there, I've told you everything that you need to know. But it wasn't enough for a lot of people. So in Markdown, back quote is like, oh, make this code. So what's this for? This is does that make sense? So all that made sense, but then everyone seemed to, I mean, and I thought if you're reading the book, you know, he talks about changing this instead so that now you have, you know, essentially the old state map is the composition of the ENVV and the store map. You got to go through both of them. First, you look up in the environment X for X, and that gives you the location, and then you apply S to that location, and it gives you the integer. Now, we almost have time to like talk about though that there's kind of like 3 different implementations. One is, you know, use lists. So I guess first of all, I should say like, note that ENV, ENVP, and store are all finite functions. Why are they finite? Well, like the only way something gets added into them is executing the programs, and we don't have any infinitely large programs. So an environment is only going to have a finite, any environment or store is only going to have a finite number of entries to it. Now that leads that to three. You could use lists, and so like here like env v is a list of pairs of identifiers paired with locations. And then this one is identifiers paired with statements and an envv and an envp. Now we could also use Haskell Maps. And then you'd have like type now you'd have to load them, of course, but okay, so what is store? Someone help me here.
Location.
Yeah. Loc, comma, int. Good. And so then down here, a type store could be, if we're using maps, a map from loc to int. And the third option is, oh, well, use Haskell functions. And then you get this, and then you say, oh, it's identifier arrow loc, or it's and this one's an identifier. Oh, that shouldn't be. Oh, this should be the P. And then this should be the triple. Now, in each case, you're going to need a few utilities. You're going to need one to, look up a value and insert a new value. Or, update, I think, And if you have those, you could use any of these data structures. You could use lists, you could use Haskell Maps or functions. To implement the mathematical concept. Okay, I went over 2 minutes, sorry. Adios.
See ya.
Have a good break.
Hey, thank you.
Yeah, I know I'm looking to having a little bit of lowered stress. I can have office hours tomorrow.